He given some of the geometric means 5, 9, 11. So we don't know which terms they are in GP. Let us assume that these are Lth term is 5, mth term is 9, nth term is this. Let A be the first term. In general terminology, AR power L minus 1 is 5, AR power M minus 1 is 9, is equal to 11. So divide one with other, which you get R power L minus M is 5 by 9. Here it is 2 by 3, which gives R power M minus N is 9 by 11. So here from this, R will be 5 by 9 whole power L minus M is 1 9 by 11 whole power 1 by M minus N. So raising to the power L minus M into M minus N, it becomes 9 by 11 in power L minus M. So here it is. These M and N are integers. So 9 power L minus M into 9 power M minus N is 5 power M into 11 power L. 5 power M into 11 power L. That is 5 power M minus N into 11 power L minus N. So here L and N are integers. So only possibility here it is in powers of 9. It is in terms of 511. They are equal only when L equal to M equal to N. So for same value of LMN, you will not get three different terms. So there is no such GP with these three numbers. Second question. Here is one is circle. Other is parabola. So here the equation given as x square plus y minus 12 whole square is equal to 1. Another is y square equal to 4x. Shortest distance occurs along a common normal. So at any point on the parabola in terms of parametric coordinates, so slope of normal at this point is the slope of tangent. Let us find out. dy by dx is dy by dt by dx by dt. It is slope of tangent. Slope of normal will be minus t. Here it is 0, comma 12. So that is 2t minus 12 by t square is minus t. So 2t minus 12 is minus t cube. T cube plus 2t minus 12, 0. So value of t is 8 plus 4 minus 12. The point here is 4, comma 4. Here, whenever you are solving differential equation, first you find dy by dx to decide the model. So dy by dx is y square by, it is neither homogeneous nor variable separable. Possibility is linear differential equation. Take dx by dy, is dx by dy plus 1 by y square of x. So dx by dy plus dy of x is q of y. Here p of y, 1 by y square, q of y is integral p dy. So for linear differential equation, x e power minus 1 by y, q here is take 1 by y as u, 1 by y square dy is du, x e power minus 1 by y, 1 by y cubed. Here e power u, dy is y square dy, which is 1 by u square du. You get cancel, minus e power u du. Integral e power u. So x e power minus 1 by y is minus e power minus 1 by y into u minus 1 plus sum of equations x plus 2y plus z plus 1. So consider the augmented matrix 1, 3, 4, 1, 1, 5, 10 k square as a solution. Then number of values of k. So here it is. Let us replace R2 with R2 minus R1. R2 with R3, R3 minus R1. Then you have 0, 1, 3k minus 1, 0, 3, 10 minus 1, k square minus 1. R3 is replaced by R3 minus 3 R2, 1, 2, 1, keeping this as this. Here k square minus 1 minus 3k plus 1. So 1, 2, 1. K square minus 3k. So here if k square minus 3k is not 0, no solution. If k square is equal to 3k, then rank of field, so infinite solution. That is possible for k equal to 0, 3. For two values of k, you have solution for the system. A variable point P on the ellipse of eccentricity, locus of incenter of an ellipse. For an ellipse, S dash comma S are foci. P is any point. As P changes, triangle changes, incenter changes. So different triangles, different incenters. That incenter definitely forms a one curve. That curve is, he said, already ellipse whose eccentricity. So here it is minus AE comma 0, AE comma 0. Any point on the ellipse, A cos theta, B sin theta. For finding incenter, this distance we know it. Here is a directrix. So SP by PM is equal to E. SP is E times PM. Here PM, this is say X, A by E minus X. So X is A cos theta. Here you have another directrix. This is S dash P. Sorry, this is SP. Regarding S dash, for S dash focus, you have another directrix. It is N. S dash P becomes E times Pn. That is, this distance is A by E plus X. A plus AE cos theta. Now we have a triangle S dash SP. It is 2AE. S dash will be into 1 plus E cos theta. Here SP will be A into 1 minus E cos theta. It is A is 0 minus A is 0. A cos theta comma B sin theta. For incenter formula, AX1 plus AX2 plus CX3, where ABC are length of the sides, AY1 plus BY2 plus CY3 by A plus B plus. Here, let us start taking X1, Y1, X2, Y2, X3, Y3. In center will be minus, this is opposite is A into 1 minus E cos theta. This vertex plus A into 1 plus E cos theta plus 2AE into A cos theta by adding all those 2AE plus AE cos theta, A plus A minus AE cos theta. This is only X coordinate. Y coordinate 0 into opposite side. Here 0 into opposite side plus 2AE into B sin theta by same A plus B plus C, that is 2AE plus 2A. So now here, which is A square E, 2E cos theta plus 2 cos theta by 2A into here 2A get cancelled. This is the point for which we have to find the locus. So A get cancelled, AE by 2 cos theta 2 into E plus 1 by 2 times 1 plus E. So BE sin theta by get cancelled. H here X comma Y. A cos theta comma. So here it is D sin theta by 1 plus cos theta here is X by E. Sin theta is Y into B plus C by sin theta was for all theta. So X squared by A square is square plus from here B square is squared by 1 plus C whole square is A square E square into the 1 minus C1 square. So B square is whole square A square into 1 minus C1 square. 1 minus C1 square is 1 minus C by. So E1 square is E1 here is 2E by 1 plus. No doubt it is a lengthy problem, but all recent main papers contains more than 50% lengthy problems. So the ranking will be decided relatively. So some of the good questions I given in the exam paper. Here it is. Consider all functions that can be defined from 1, 2, 3 to 1, 2, 3, 4, 5. Here, condition is I less than j, fi must be less than fj. So, domain is A, codomain is B. In case 1, here distinct elements has distinct images like this 1, 2, 3. How many such mappings are there means from 5 elements of domain we can select 3 in 5C3, that is 10. So don't go for permutation, because if you take, suppose you take 2, 3, 4, it is F1, it is F2, it is F3. Question is F1 must be less than F2. So permutation means 3, 4, 2 also possible. Here F2 is not less than, F2 is not less than F3. So only selection you have to do it 10 ways. Case 2, possibility. Here it is. We have to select only 2 elements, like 2 elements can be selected in 5C to 10 ways. But here, once you select 2, 3, here 3, 4 possible mappings, 2, 3, here it is. If you select 2 elements, possibility is, suppose you selected 3, 4, one function is 1, 3, 2, 3, 3, 4. Other possible mapping is 1, 3, 2, 4, 3, 4. So for each selection, there are 2 possibilities. For 10 selections, 20 possibilities. Another case what we have is all element maps to same element. So in case 3, such functions are 5. So total functions will be 10 plus 20 plus 5, 35. Probability will be 35 by 5 cube. 700. Here, why denominator is 5 cube? Each element can be mapped to 5 elements. The denominator n of s, first element can map to any one of the 5 elements. Second elements like this. Total functions are 125. Here, mod z square, to find minimum value, we have a inequality. Z1 plus Z2 is less than Z1 plus Z2, which is also less than mod Z1 minus mod Z2. So if you take this, mod of Z square minus 1 is less than Z square plus 1. which he given it as 4 times mod z. Mod z power n is mod z whole power n. In one case, it is less than 4 mod z minus 4 mod z minus 1 less than z. So mod z here is, if you solve this, roots will be minus b plus or minus 4 plus or minus root 16 plus 420 by 2, that is 2 plus or minus 1. Mod z cannot be negative. So mod z lies between 0 and 2 plus root 5. So this is one possibility. So another possibility here is mod z square minus 1 of minus, which is less than 4 mod z. 0 less than mod z square plus 4 mod z minus 1. So here it is, roots will be minus b plus or minus here minus 1. Here 1 minus z square. Okay. So that is mod z will be less than minus 2 plus root 5. And mod z is greater than 2 plus minus 2 plus root 5. So mod z cannot be negative. So mod z is greater than or equal to root 5 minus 2. So now other possibility, mod of z1 plus z2 is mod z1 plus mod z2. From this, mod of z square plus 1 is less than mod z square plus 1. So z square plus 1 here is 4 mod z. So mod z square plus 1 greater than 4 mod z plus 1 greater than 0. From here, roots are 4 plus or minus 16 minus 4 by 2a. 2 plus or minus 2 root 3, that is 2 root 3. Mod z is less than 2 minus root 3, or mod z is greater than 2 plus root 3. So mod z cannot be negative. So 0 to 2 minus root 3, or mod z is greater than 2 plus root 3 to infinity. And here it is, since we want a minimum, there are 2 minus root 3. Another condition is here, it is greater than root 5 minus 2. So the common part, so here minimum, which implies mod z minimum is root 5 minus 2. Definitely we get a doubt, which is more. This you take root 5 minus 4, root 5 minus 3, say it as p comma q, rationalize. You get 1 by root 4 plus root 3. So denominator is more, it will be lesser. So root 5, so the minimum value is this. Here let us say this is r bar. So r bar dot a bar, if you take a dot b, by of dot b bar, let us say b dot b will be mod b square by mod b square. C dot b 0. Here b cross c dot b will come. That is also c. So r dot b will be a cross b. Similarly, r dot c, if you do it, first one 0. A dot c into c dot c by here, it is also 0. So that is r dot c is a dot c. Similarly, r dot b cross c also you get b dot b cross is 0, c dot a dot b cross. From these all informations, we can say r bar as a bar. Here it is determinant a into bc minus 1, c minus 1 plus 1 into 1 minus b. Minus a minus c plus 1, which is abc minus a minus b minus c plus 2, is positive, he told. Arithmetic mean. So ABC plus 2 is greater than A plus B plus C, which is greater than or equal to 3 times cube root ABC. So ABC, if you take it as x cube, we get here is greater than 3x. X cube minus 3x plus 2 greater than 0 is a factor minus 8 plus 6 plus 2. So that to find out remaining factors, so this cubic expression I can write x square minus 2x plus 1 greater x plus 2 into x minus 1 whole square is positive. X plus 2 must be positive. X greater than minus 2. Cube root of ABC is greater than minus 2. ABC is greater than minus 8. So, second option. So here you assume x square plus x as a minus 2 into a minus 3, 12. 5a plus 6 minus 12, 0. So a minus 6, a plus 1, 0. So x square plus x minus 6, 0. For this discriminant is b square minus 4ac negative. You get non-real roots. Here you will get discriminant positive real roots. He's asking sum of all non-real roots, which is minus 1. Here is involutionary matrix. The square is I. So inverse of Ka will be 1 by K times inverse of A. Inverse of half A will be, which is 2 times inverse of A. Here A into A is I, which implies inverse of A is the answer. Here a ray of light passing through 3 comma 2, reflected at 0 comma beta on y-axis and passes through C4 comma 3, then beta equal to. Take its reflection. This distance and this distance are equal. Then reflection of C, let us say D. If you join this, then BADR collinear. Here it is 4 comma 3 with respect to y-axis. Reflection will be minus 4 comma 3. So now BA slope is equal to BD slope. So 2 minus beta by 3 is equal to 5 by 7. 14 minus 7 beta is 5 by 7. Sorry, 2 minus 1 by 7 minus 3. From here, beta is 17 by 7. So here direction ratios of AB and AC 1, 2, minus 2, 2, minus 3, 6. This model he didn't touch in the first mains, phase 1. So this model you can expect. So here to find the direction ratios of angle bisector, you consider unit vector so that AC length and AB lengths are equal. When AC AB lengths are equal, angle bisector will be along the diagonal. So unit vector means 2 by 7 minus 3 by 7, 6 by 7 is a unit vector. Here along AB, 1 by 3, 2 by 3, minus 2 by 3. So these are DRs, A1, B1, C1. Here A2, B2, C2. So DRs of angle bisectors will be A1 plus A2, B1 plus or minus B2, C1 plus or minus C2. So possibility 2 by 7 minus 1 by 3 minus 3 by 7, 6 by 7 plus 2 by 3. So 6 minus, here it is 36, 7, here it is, okay, 6 minus 7 minus 9 minus 23 by 21, 18 plus 14, 32 by 20, which is also same as DR's 123 minus 32. Third option is correct. Here, so this one, let us solve this limit with the help of sandwich theorem. Because step value is there, step of x lies between x minus 1 and x. So based on that, the step of 1 square x plus 2 square x, so on, step of n square x will be less than or equal to 1 square x plus 2 square x plus n square x, which is taking x common, sigma n square x. What sandwich theorem says? If h approaches to some number, g approaches to some number, f also approaches to some number. Limit n tends to infinity about h upper boundary by n cube. Limit n tends to infinity sigma n square n into n plus 1 to n plus 1 by 6 x by n. Yes, this will be n cube here, n cube. Then we take a ratio of highest power, coefficient of highest powers 2 by 6, which is 2x by 6, which is x by 3. So similarly, lower boundaries, if you consider, so what we get here is x minus 1 means 1 square x minus 1, so on up to n square x minus 1. Adding all those will be less than or equal to 1 square x on n square x. Finding limit for this, limit n tends to infinity, sigma adding all those x minus n by n cube. So this also limit n tends to infinity, sigma n square of x by n cube minus 1 by n square. As n